You know, our solar system is absolutely screaming through the Milky Way at something like 828,000 kilometers per hour. It's just an insane speed. But what if I told you that the map of the solar system we all learned in school is just fundamentally wrong? Okay, let's dive into this because we're about to explore the true three-dimensional journey that we are all on right now. Even at that mind-boggling speed, it still takes us about 230 million years to make just one single trip around our galaxy. I mean, think about that for a second. The last time our solar system was in this exact same spot, dinosaurs were just starting to show up on Earth. We tend to have this picture in our heads, right? Of our cosmic trip being this neat, flat lap around a racetrack. But is that really what's happening? Is everything just perfectly lined up on one single plane as we barrel through the cosmos? Well, the answer, and this might surprise you, is a definite no. So let's start by totally tearing apart that old familiar map. It's time to redraw how we picture our solar system's layout and really see why that two-dimensional diagram we all had to memorize, well, it just doesn't tell the whole story. Not even close. Yeah, we all know the view on the left, don't we? That clean, orderly line of planets, all on a single, flat plane. But the reality, what's actually happening out there, is the picture on the right. It's so much more of a beautiful mess. It's really a 3D dimensional dance of tilted, overlapping, and intersecting paths. And this table right here just makes the point perfectly. Sure, most planets are kinda close to the main plane, but they're not perfect. Look at Mercury, it's tilted by 7 degrees, and the dwarf planet Pluto, a whopping 17 degrees. But then you get comets like Halley's, which is so extreme at over 162 degrees that it's basically orbiting backwards compared to everyone else. Our solar system is anything but flat. So this brings up a pretty good question. If everything's so tilted and messy, how do we even know which way is up or down in space? I mean, without gravity pulling us toward a floor, we have to create some really big reference points just to get our bearings. Okay, so our first reference point is actually the one our flawed map is based on. It's called the ecliptic plane. All it is the flat plane that contains Earth's path around the sun. And even though we know it's not the whole picture, it's still the foundational grid line we use to measure pretty much everything else inside our solar system. Now let's zoom way, way out. Just like our solar system has the ecliptic plane, the entire Milky Way has the galactic plane. This is that huge, flat disk where you'll find most of our galaxy's stars, gas, and dust just hanging out. It's the big reference point for our solar system's much, much larger journey. So, with our cosmic coordinates now established, let's go on a little journey from the inside out and discover what the true shape of our solar system actually is. And trust me, it's way grander and a lot stranger than just a bunch of planets on a disk. Our trip to the edge is going to take us through 4 pretty distinct layers. We start off in the dusty haze of the inner system. Then we push through the famous Kuiper Belt, that big ring of icy bodies. Past that is the scattered disk, which is exactly what it sounds like. Just a chaotic region of scattered objects. And finally, we get to the most mysterious region of all, the Oort cloud. And here it is. This is the big reveal. That final layer, the Oort cloud, isn't a disk. Not at all. It's a massive theoretical sphere made of trillions of icy bodies, and it completely surrounds our entire solar system. So here's the key takeaway. The true shape of our solar system isn't a flat disk. It's a sphere. And the scale of this sphere is, well, it's almost impossible to really comprehend. The Oort cloud might stretch out as far as 3.2 light years from the sun. That is more than halfway to the next nearest star. Our sun's kingdom is truly, truly vast. But wait, there's another invisible structure that defines our solar system's boundary. It's a protective bubble, a shield that protects all of us as we travel through the empty space of the galaxy. This bubble is called the heliosphere. It's created by the solar wind, this constant stream of charged particles just flowing out from the sun. The best way to think of it is as the region where the sun's breath is stronger than the wind of the galaxy. This is the true edge of the sun's domain. And hey, this isn't just a theory. We've actually been there. Back in 2012, Voyager 1 crossed this boundary. It's called the heliopause, above the solar system's main plane. And then, 6 years later, its twin, Voyager 2, did the exact same thing, but below it. Together, they gave us the very first direct proof that this protective bubble really does surround us in every direction. Okay, so now that we've officially crossed the border of our solar system, what's immediately outside? What galactic neighborhood are we flying through right now on our 230 million year orbit?
Right now, our entire solar system is moving through a 30 light year wide wisp of gas and dust called the local interstellar cloud. But this little cloud itself is floating inside a much, much larger structure, the local bubble. It's a 1,000 light year wide cavity of almost empty space, and it was probably carved out by ancient supernova explosions millions of years ago.
But believe it or not, there are even larger structures out there. These vast, invisible giants that just dwarf everything we've talked about so far. They loom high above and deep below the galactic plane, and they're completely invisible to the naked eye. And here, the scale is just staggering. In 2010, astronomers found two enormous structures erupting from the center of our galaxy. They're called the Fermi bubbles. Now look at this chart. Our whole galactic disk, where almost all the stars are, is only about 1,000 light years thick. But these bubbles, they extend 25,000 light years above and below it. They are basically the ancient ghosts of some colossal eruption from our galaxy's central black hole. And finally, that brings us to the biggest mystery of all. This invisible substance that is everywhere, existing above, below, and all around us. It's been described as the hidden scaffolding of the cosmos. And it is, of course, dark matter. Here's why this is so unbelievably important. Everything we can see, every star, every planet, every galaxy, all of that only makes up about 15% of the total matter in the universe. The other 85% is this mysterious, invisible dark matter. And without its gravitational pull, galaxies like ours would just spin themselves apart. It is literally the glue holding everything together. So we've gone from a flawed 2D map to this incredible 3D reality of nested bubbles and invisible halos. Our understanding of our place in the universe is just constantly changing. And it leaves us with this one final, pretty profound question. If so much of our cosmic neighborhood is completely unseen, what other invisible forces and structures are out there guiding our journey?